Alright, so we're going to be looking at section 6.2, which is going to be the area in between curves. So here's what we're going to be doing. So we are going to be looking at trying to find the area in between two functions. So let's say that here we have a function f of x, and here we have a function, let's say that this is g of x. What we are going to be interested in doing is that we want to find the area that is in between these two curves. So we would like to find the area between these two curves. So this area here. So in order to find the area in between these two curves, what we are going to do is that we are going to take the area from a to b of our top function, f of x. We are going to subtract the area of the bottom function, g of x. Okay? Which, by the way, since this since we're subtracting two integrals, we can actually just put them together under the same integral. So what you can think of this is you can think of this as the integral of the top minus the integral of the bottom. Okay. Now, before we move on, I just want to do a quick little explanation of why this works. So, the reason this works, if we look at a function, let's try to do a little bit better than that. Let's say that we are looking at a function, f of x, and let's say that f of x and g of x are both above the x-axis. So this would be f, this would be g, and let's say we're looking between a and b. Well, if we look at the area of f of x, so let's say that the area of f of x looks something like, let me get a different color. Let's say that the area of f of x looks like this. And then the area of g of x, say that that's this blue, looks like this. Well, then clearly if we want to find the area in between f and g, well, we're going to find the total area underneath f and the x-axis, and we're going to subtract this area g, and that's going to leave us with the desired area here. Now that makes sense if they're both above the x-axis, but what happens if one of our functions is below the x-axis? Then does it still make sense? So let's take a look at this. Let's say instead that, well, let's keep f of x above the x-axis, so let's go say that we have f of x here. Okay? And let's say now that g of x is below the x-axis. And let's say that we still want to find the area between f of x and g of x between a and b. Well, if I find the area between the x-axis and my function f, that's going to look like this. Okay? And now, if I find the area between g of x and the x-axis, it's going to look like this. Now, am I still going to use this formula to find the area in between them? Well, yes, I am, and here's why. This area is positive, while this area is negative. But remember, when I'm doing this, I'm subtracting that negative area. So subtracting it is going to make that area positive, which means I'm going to be having a positive area plus this positive area. That leads us to a little given, which is that your answer should always be positive. Alright, great. So the same thing works if we're looking at both of the functions being underneath the x-axis. So even if they both have quote-unquote negative area, the arithmetic will work out so that we still get a positive answer. So you should try to write out a couple examples and prove that to yourself. So actually, you know what? This is a great time to look at some examples. So let's get this off the screen. And let's go ahead and start looking at an example. So let's look here. So we are looking at finding the area between this function f of x, which is this cubic function here, and my function g of x, which is this quadratic. We want to find the area between -1 and 3. So let's go ahead and color in the area that we are looking at. So bright green, I like bright green. So we're trying to find the area in between these two. So we're trying to find this area here. Alright, cool. So notice that our function, our cubic function, or I'm sorry, our quadratic function, is above the x-axis and then dips below the x-axis. We actually don't need to worry about that. The only thing we need to worry about is which function is on top and which function is on bottom. That's all we need to worry about. So we don't need to concern ourselves with whether our functions are below or above the x-axis. So to complete part A, what we are going to do is that we're going to take the integral from -3 to 1, and we're going to take the top function minus the bottom function. So our function that is on top of this area is going to be the cubic f of x. So we're going to have x to the third plus x squared minus, sorry, I wrote 6, that should be 6x, plus 5 dx, minus, and then we want to subtract the area of the bottom function, which is x squared plus x minus 1 dx. Now remember, you can write this all together in one integral. I'm just writing them separately. I'm not going to lie, it's because I'm running out of room a little bit over here. So, if you find these integrals and evaluate them, what we are going to get is that this area here is equal to 32. So that's our answer. The area in between these two functions is 32. Now for the next one, what we want to do is that we want to find the area between 1 and 2. So we want to find this area right here. Oh my Lanta, that is still an ugly color. Let's go back to that pretty green we were using. So we want to find the area in between them right here. Okay? So in order to find that area in between them, well, notice that after they intersect here, my top function is now the quadratic x squared plus x minus 1, and now my bottom function is the cubic x cubed plus x minus 6x plus 5. So that's okay, because all that means I have to do is if I'm looking between 1 and 2, I just have to switch the order in which I'm subtracting them. So my top function then is x squared plus x minus 1. And from that area, I need to subtract the bottom function, which now my bottom function is that cubic. So it's going to be x cubed plus x squared minus 6x plus 5. Yeah. And if I evaluate that one, what I'm going to get is I'm going to get an area 3/4. Now for part C, it asks me to find the area between -3 and, oops, I'm sorry, that should say the area between -3 and 2. So if I want to find this area and this area together, well, all I have to do is take my two answers and add them together. So the final solution for part C is I would have 34 plus that 3/4, which would equal 131/4. So remember, if it switches from one function being on top to the other being on top, then you have to do two separate calculations. Alright, let's look at one more example before we wrap this video up. So, let's get rid of this, and let's take a look at this example now. So what we want to do here is we want to find the area enclosed by the function f of x equals sine of x, which is this top red function, and the function 0.5 sine of x, which is this green function, on the interval from 0 to 2 pi. So let's talk about two different ways we can do this, and before we start talking about those ways, I always just like to highlight the area I'm looking at. So, I'm looking at this area in here, and I'm also looking at finding this area in here. Alright. So first what I'm going to notice is that if I look at the area between 0 and pi, so between 0 and pi right here, I notice that my function f of x is on top. Whereas if I look at my function here, after they intersect, I notice that they change directions. So there's two different ways I can do this. I can find the area from 0 to pi. And I'm going to have my top function minus my bottom function, so it's going to be sine of x minus 0.5 sine of x dx plus, and then here I have to set up a new integral because now my top function is 0.5 sine of x, and now my bottom function is sine of x. So remember, I'm just looking at the area and I'm thinking what function sits on top and what function sits on bottom. So that's going to be plus the integral from pi to 2 pi. Now my top function is 0.5 sine of x minus my bottom function, which is now sine of x. So then after I evaluate that integral, what I would get is I would get something, and I believe it's about 1 point, let me just double check, 57. Okay, so that's one way you can do this problem. The other way that you can do this problem is that we can look at this graph, and we can note that these are both periodic symmetric functions. So that means that this area here is going to be the same as this area here. So another way that I can do this problem is I can just find the area from 0 to pi and then double it because those areas are going to be symmetric. So do this, then multiply it by 2, and you will get the same answer.